Good day, academians. Welcome to Study with Mr. M, known as the Maths and Science Academy. Now, today we're doing the last function, of course, in our level. Now, I want you to be introduced to what we call the logarithmic function. Some teachers may call it the log function. I also call it the log function, but I wrote this word in full just to flex. I'm just playing, guys. I always say I'm playing, but I'm not playing because we're not playing it. We want to pass. It's late. Let me focus. Now, a log graph or a log function is its own function. Why are you telling us this? Because I've taught a lot of people who are making the same mistake. They're thinking that an exponential is the same as a log function, but they are not, right? An exponential is its own function and a log is its own function, right? Now, why do people make that mistake? They make that mistake because a log graph is a result of finding an inverse for the exponential. Now I'm going to show you how we arrive to that point, but just know that a log graph is an inverse of who? Of an exponential graph. Now there's a method that we use in terms of how to deal with logs in the academy. We call it the ABC to CBA method. Now you see there, the ABC starts in a normal sequence, and then the CBA, they just go backwards. Now I want you to remember this, right? This is how we're going to do it, right? A, right, is equal to B to the power of C. Now you take this thing, as you see it goes like this, A, B, C, you take it backwards, right? Now C is equal to log, introduce the log, then there's a base, right? So that base is going to be the one that is carrying the exponent, right? Which in this case is B, and then in the bracket you're going to put what it was initially equal to, which is A. Now if you look at this, you said A, B, C to what? To C, B, A. Now don't forget that method. I'm not going to waste too much time on it, but I want you to remember that. Now for example's sake, if you want to do something like this, because I know you guys, you'll want an example, right? Let's say you want to do, let's say 5k, right? Now what you're going to do there is you're going to say the same thing, right? Do the same thing. You're going to take the k and drop it, drop the k, right? Then put log, right? As the base must be the one that is carrying who? The exponent in this case is who? Is 5. Then there in the bracket you put what was initially equal to the base, which is just y. I know it is uncomfortable for now because maybe you've just started, but you'll get used to it. Now I want you to remember this. With logs, I don't know, maybe your teacher or whatever or whoever told you, respectfully, please do not use the original graph, the exponential, the inverse, right, which is the log. So don't use the original log graph. Always try to take, if they give you a log, always try to take it back to this one and deal with it that way, right? When you get comfortable, you can then start to flex and just work with the log alone. But if you're still trying to find the accurate answers, still trying to not make mistakes, please, when they give you a log, go back to the exponential, right? Because as you know, an exponential, when you find an inverse for an exponential, you're just essentially going to be finding the log. And I'm going to show you, I've essentially showed you over here, but of course you maybe want the proper example, and I'm going to show you that too. Now why am I saying do not use the log? Because it's very complicated, right? Because over here there's a restriction. Over here we can never have 0 or a negative value over here. So a over here, a will forever be greater than 0. So you think these are restrictions that can make your life very hard. Sometimes you can forget that, and then you put it in an exam, you get an error, then you're thinking, oh, I did something wrong, but you don't remember that I said to you, always convert it back to what? To the exponential, because it's easier to deal with that way. Now I want us to use what? The mirror technique. What is the mirror technique? I want you to remember this. If you are asked to calculate or to determine the domain of the original. So let's say, for example, you have original, let's say then inverse. Right now, of course, here you'll have an exponential, then here you'll have the log. Right now, what I want you to do here is that if you have the domain, right, if you have the domain and the range, this is what I want you to do. Always, this is what I want you to do. Always take or always go ahead and find the domain and range of the exponential, and then you swap them around. So the domain for the exponential will be the range of the inverse, and the range of the exponential will be the domain of the inverse, which is what? Which is just log. Now we've done those and y inverses. You interchange the domain and range, the x and y values. We've done that in the first video, so no one is going to go deep into that. Right now, also the same thing. If you see here the pattern that I'm doing, we don't really deal with log directly, but even if we solve for log, we're just going to use this one and use the mirror technique. The mirror technique now says that if we have the original, we're just going to take everything of the original, swap it around, which will now make it belong to what? To the inverse. So that is the mirror technique. Even with the coordinates, you can calculate the coordinates using the exponential, then you swap them around, they'll give you the coordinates of what? The log graph. Now, steps for drawing. I want you to do the same thing again. We're still using the mirror technique. Even for drawing, we say that you find the x and y intercepts for who? The original, which is who? The exponential. And then you swap them around, just like I said, the mirror technique. Find a random point and plot it to find the shape of the graph. Now, I know there's a lot of people who know the strategy. A, B, x plus minus p plus minus q. The one of looking at A or B, I know that's very tedious at some point. I think we should find a way to make it better, and that way to make it better is to plot a random point, right? But somehow, to some extent, we still need to know the basics of an exponential or any graph for that matter, so we can be able to know when we are wrong. Then after that, which is step 3, you just draw and label the graph. But as I said, the mirror technique always works perfectly. Now let's deal with this example directly. Now this example, you see here the exponent is a variable, so we can know that this is an exponential. Now let's say if you want to find the inverse of this exponential, you're going to be essentially finding log. Right now, how do you then change this one? I said to you, use the APC method. What is the APC method? It's equal to ABC. How do you change this? C is equal to log BA. APC to CBA. Now let's remove this. Of course, you've noted it down in your notebook. Now watch and learn. We say that every time when you find an inverse, what do? You swap x and y. So let's do that. Let's swap x and y. So here I'm going to have x, I'm going to have x, then here I'm going to have y. Now find y by itself. Now to find an exponent that is a variable, we use logs always. So now we're going to use the APC to CPA method. In this case, we're going to CPA, so we're just going to say y is equal to log the base that is carrying the exponent. In this case is 2, and the bracket you put to x. Now I want you to always get into the habit of saying this. Always say this when you have a log: x must be greater than 0. Because if let me try to put it in my calculator to prove to myself that it works that way always. Let's say 2 and minus 3. There is no log of a negative number or whatever, right? So that's why I say you must always deal with this original and then you solve the points, because this one is very complicated. As you see, it goes with a restriction. Of course, in an exam, there's no mark for that restriction. They don't even expect it sometimes, but because you're part of the academy, I want you to know that there is a restriction. Now, you found the inverse, right? Now, let's say you label that y minus 1, right, is equal to log 2, then there you put x. That is your log, right? Now, I want you to do something for me, right? I want you to draw, of course, we're going to do it together, but I want us to find the x and y intercepts. But I said to you, we are not going to be using this thing over here, because once we try to find the y-intercept, we're going to want to put 0 over there, and we said that x cannot be 0 in a log because it's going to give you an error, right? Now, log graphs are very complicated and very sensitive, so you always have to deal with the original, then you swap around. Are we together? Fine. Now we found the inverse equation is fine. Now let's go ahead and try and find the x-intercept. Right now, you see here, find the x and y intercepts for the original and then swap them around. What are we trying to do? We're trying to draw. Right now, before we go anywhere, let's find the x and y intercept. Now for the x intercept, right, what do? You let y be equal to 0. Right now, what you're going to do here is that you're going to get 0 is equal to 2 to the x. Then, as I said, always when you try to find an exponent that is a variable, then you're going to see that x, the ABC to CPA method, log 2 of 0. What did I say about this? I said there is no log that is a 0. So here you can see that x is a no solution. What does this mean? It means that our graph doesn't have an x-intercept, and it's fine. Do not worry. Sometimes the graph does not have a y-intercept, or do not have an x-intercept at all, right? And sometimes the graph doesn't have a y-intercept at all. Now it means here there is no solution for both the inverse or the original, so there's nothing that we're going to swap over there. Then there we're going to find now our y-intercept. What do we do for the y-intercept? We let x be equal to 0. So let's go ahead and do that. I say y is equal to 2. For the x part, we put 0, and anything to the power of 0 is just 1. And I said to you when we started, the coordinates of the y-intercept, the x value is going to be always 0. So let's go ahead and put that. Let's say 0 and 1. Now here, this is for the original. Now I want us to go ahead and take the points to be an inverse. Now let's go ahead and swap them around. So now for the inverse, I'm going to have 1 and 0. Are we together? Are we together? Yes. Now we've found the x and y intercept. Let's go ahead and find a random point. Now let's substitute x is equal to 2. Let's just say x is equal to 2. Now when you substitute x is equal to 2, we're going to see y is equal to 2 to the power of x, right? Now let's put 2, because we're substituting y is equal to 2, x is equal to 2 rather, so we're going to get 2 to the 2, then y is going to be 4. The coordinates here will be what? 2 and 4, right? Because we put 2 in the value of x and we found what? 4. So here 2 and 4, but these here are for the original. The original is what? The exponential. Like I said, the mirror technique, you always use the coordinates of who? Of the original. You swap them around. The mirror technique, you always find the exponential coordinate. Now here we're going to be going to the inverse coordinate, which is going to be 4 and 2, because we're going to swap them around. Now I want us to go, this is a standard exponential, so there's no fuss about it. I want us to draw fast. This is just a simple thing, right? Fast. Yep. Now let's go ahead and plot those points. Now both of my coordinates here are positive, so that tells me they are in the first quadrant. So where is x going to be? 4. Let's say maybe somewhere over here. Let's say it's somewhere over here. And where is y equal to 2? Let's say it's somewhere over here. Then those points, of course, let's say it's somewhere over there. Because of course we're not drawing anything up to scale as for now, but in an exam maybe they would expect you to draw, not maybe, but they would expect you to draw something that makes sense, right? Now again, we're going to continue. You see, we didn't look at a values, b values, whatever, but of course what I want you to focus on only in this equation, in this standard form. I know it's very hard to digest. I know it's very hard to digest, but we're going to get used to it. Now I want you to only look at the a value, so you know whether it's above or below. whether it increases or decreases, let the random point sort that out. And I'm going to prove to you that the random point technique always works. Now, is there any other coordinates that we must sub in? Yes, we said that is 1 and 0. So, of course, 1 and 0 will be over here. So, over here. Of course, yes. Now, what did I say to you? This is an exponential, so it must have an asymptote, right? But it's an inverse if you look at it, because if it was the original, which is the exponential, it was going to be either above here or below here, right? Whether decreasing or increasing, that doesn't matter, right? Now, because there were no p and q values, it means that for this standard exponential, what would be the asymptote? It would be the x-axis, right? But because since we're dealing with inverses, what was the asymptote for the original? It was the x-axis. So for the inverse, it must be the what? The y-axis. So just like that, you must know that our graph must never touch this point over here. And just like that, you graph here, even if you see, if you try to draw a curve here, your curve will be like something like this, something like this, something like this, right? And you see, just by doing that, you didn't have to go ahead and know the b, how it must look like, whatever. You just went ahead, took the original coordinate, swapped them around, found a random point, and that random point, which is 4 and 2, was the one that directed you to this curve. Now I say to you, you must always label your graph. If you want to label your graph, you should say that it's y minus 1. Now, for interest's sake, I want us to go ahead and label and plot the original too, so you see what I mean when something is inverted, because I once showed you an exponential, and you've seen some exponential are just like this, or like this, or like this. So when you see something that is going on the side like this, it is very complicated. It is very interesting for me, at least. Now let's go ahead and draw the original. So 2 and 4, who would define 2 and 4? 2 and 4, that would be somewhere high up over there, right? Somewhere high up over there. Let's say 2 and 4. Then let's say maybe another point, which is 1 and 0, 1 and 0, 0 and 1, maybe 0 and 1, 0 and 1, 0 and 1, 0 and 1. Now, just like that, you don't need anything else. You just need to draw your curve, and it does that. See, did you need to go ahead and plot but the p-value and whatever and whatever and whatever and whatever? No, you didn't, right? Now, I want you to remember this. This one, let me highlight it. This one, let's highlight it. This one is in blue. Yes, this one that is highlighted in blue, that is the original, right? That is the original function. Now I want you to look at something here. If you were to look at this line of symmetry, axis of symmetry, and you took this graph and folded it to the other side, it would fit right into this one. Of course, we didn't drop to scale, but if you look at the shapes, it would fit right back to this one, right? Because it's an inverse function, so it's just a mirror. Hence, the mirror technique works, right? Now, I don't want us to go deep into it because there's really nothing deep about it. What is following is just you understanding how to apply this in an exam setting, right? Of course, I've taught you how to draw, how to find the inverse of an exponential, which is just the log, and how to use logs. And I'm sure by now that you will be practicing more past papers to get better. And of course, we'll be continuing with past papers. So right now, in terms of functions, the only thing that I owe you is past papers, because I'm happy with the progress and how people are actually receiving the content from functions. And for now, I only want us to focus on past papers and application before we move to trigonometry, guys. So from me to you guys, thank you. See you next time.